Hey guys, today we're going to be looking at how to model and solve two-step one-variable equations and inequalities. Now in front of us we have a model that's already given, and notice they gave us a key right here. They tell us that each long rectangle equals a positive x, the short box is equal to a positive 1 when it's not shaded, and when it's shaded in, the short box is equal to a negative 1. So I see I have an equation or an equal sign right here, which means I have a left side and a right side of my equation. Each of these long skinny rectangles will represent x, and then I have 7 shaded in units, each of them representing a negative 1. So altogether on my left-hand side, I have 3 x's and 7 negatives, which I can represent as minus 7. And all of that will need to equal the 8 positive 1s that I have on the right-hand side. So 3x minus 7 is equal to 8. Now we can use the picture, or we can use the equation that we just developed to solve it. And so I know that my goal when solving an equation is to isolate the variable, which means to get the variable all by itself. So I have 3 x's, but really I only want to find out what one of them is. And right now I have 7 negatives on the same side as the variables. So I want to do the inverse operation of that, or I want to create 0 pairs. So right now, these are all negative. So the inverse of that would be to add 7 positives. So I've added 7 positives to the left-hand side. But because this is an equation and we want to keep it balanced, I must add 7 positives to the other side. So my 7 negatives and my 7 positives on the left-hand side, they create 0. So I'm just going to cover them up with white because they are gone now. And so what remains, because I put 7 positives on both sides, the negative 7 and positive 7 created a 0, which left me with 3 x's on the left-hand side, which was equivalent to 15 positives. Again, I'm not done there. I want to find what one variable is equal to. So what I could do if I had my tiles right in front of me is I could take all of these units and share them equally. So I could have 5 go to 1x, another 5 go to a second x, which would leave the last group of 5 to go to the final x. So each x would get paired with 5 positive units. But mathematically what we're doing is we're taking those 3 x's, which is equal to the positive 15, and we're dividing them into groups of 3. And so we get that 1x, one group of x, is equal to 5 positives. And if I wanted to check my work, my original equation was 3x minus 7 is equal to 8. If I take the answer I got, which was 5, and I plug it in to what x is. So I would have 3 times 5 minus 7, and we want to see if that equals 8. 3 times 5 is 15. Minus 7, that does give us 8. So we have solved our equation, and then we have checked our work, and our solution is x is equal to 5. Thank you.